Voting for SqlBits public sessions is officially open, and I decided to refresh my text mining skills, to look behind the scene, pick my favorites, and in this video I'm going to share my findings. If you go there, I do encourage you to spend some time and read through entire list of presentations and vote wisely. The better sessions and speakers selected, the higher quality and overall value of this great conference. This year I've submitted 3 sessions, and it's additional motivation to look at others' presentations, compare, check for trends, and try to predict what are my chances of being selected. Before I dive into code, a few facts about me. I have over 10 years professional experience with SQL Server, and I'm a certified Azure Solutions Architect, but my background are wireless intelligent sensor networks. I used machine learning, mostly neural nets, to make sense of IoT data. In addition, I worked on recommender systems and used a vector space model, but by no means I'm an expert at computational linguistics. Let's start.
Project folder. All scripts are available on GitHub. SqlBits doesn't provide API access, and I'm going to harvest sessions data with PowerShell directly from their website. It's a combination of Bootstrap and jQuery, and web scraping and browser automation can be done in R with help of packages like XML and Harvest, but PowerShell in this case seems more natural to me. Here's PowerShell script. Should be easy to understand and modify if necessary. And quick sanity check. Data looks promising, and while we're here, I'm going to use a custom list of stop words. That's R script with collection of text mining helper functions. It references the TM library that provides a text mining framework, Slam for matrices operations, word cloud for generating word clouds, RWika, which is massive, but I'm using ngram tokenizer, rgraphwiz, plotting dendrograms, topic models for modeling topics, data table for aggregations and collapsing data frames. Finally, main script, but I'm going to switch to RStudio. Let's source helper functions and load data. Next, create corpus based on sessions descriptions and loaded stop words. A quick look at this function. Number, punctuations, whitespace, and stop words were removed, and remaining words stamped. There's no good reason why not to stem words. Now, term document matrix. It's an inverse and data frame with words frequencies. So we can explore term document matrix, find frequent terms. That's the function that returns all terms that occur specified number of times. Word clouds, 1 and bigrams. Interesting that data warehouse term is missing here. We can plot frequencies and cumulative distribution frequency. That's top 50 most frequent terms, unsurprisingly data on top. Notice stemmed forms. But most frequent terms are not necessarily the most interesting, and there's a high probability that different context changes their meanings. Let's look at least frequent terms. Zupla, and yeah, I've seen this session before and it was good. Go Prati. So I used that package in the past to analyze time series. Spark. Richard Conway, he's person behind London Azure user group and some IDX content, so one not to miss. TensorFlow, Laura da Silva again. It's possible to wait TF-IDF so we can get important terms. One that caught my attention is a stemmed form of in-memory, and that's because one of my sessions talks about memory optimized table types. It's a great feature that has finally become mature and available in standard edition of SQL Server. Let's look at my competition. Oh well, I did learn something new. All sessions start at minimum level 300, so gentle level 200 introduction. like write-ahead logging compared to in-memory LTP logging might be popular. Next, general data protection regulation. Yes, go me. Dendrograms. Occurrences of terms can be represented by vectors or frequencies, and it's possible to calculate distance between pairs of vectors. And there are different methods to find proximity, and I'm using cosine. First, all words. Not very informative. Let's remove terms with sparsity higher than 90%. Better. So that's hierarchical clustering, showing similar words, and proximity heat map. Next, session scope. We can apply similar methods used for terms and look for similarity between sessions. This time I'm going to use a document term matrix. Let's deal with sparsity first. Proximity between documents. There are clusters and occurrence heat map. 5 nearest neighbors and 5 opposites. Some of these are quite unexpected, and I think length of sessions descriptions come into play here. Topic modeling. That's interesting concept of unsupervised learning. Unique because a single observation can be associated with multiple clusters, which is very useful in some cases, like finding abstract topics and classifying content. Let's fit model first. Corpus is very small, and I'm going to search for 8 topics only. These are topics we found, and that's how they model sessions. Distribution over distribution of probability, so that sums to 1. 8 most probable terms are for each topic. Now most probable topics for each document. Next, all sessions that topic 6 can be assigned to. And finally, authors. I'm using a data table to aggregate data frame. This function counts submitted sessions and keeps only authors with 3 or more. Top 20 authors. That's it. Thanks for watching.